The concept of covalent bonds is what we have studied in detail in the previous video. We also concluded with the question asking what type of covalent bond is shared by carbon with other atoms. Is it a single or a double or even a triple covalent bond? How does the bond formation by carbon take place? Let us answer all the queries related to bond formation by carbon in this video. Let's begin with understanding the simple structure of a carbon atom first. As we know, it has 4 valence electrons. That means sharing of all 4 electrons is possible. Thus, the valency of carbon is the most important factor for its amazing capacity to form bonds. So if we have a monovalent element like hydrogen, how will the bond formation take place? Wait a second, what do we mean by monovalent? We know monos is 1 and valent here refers to valency. That means elements having the valency 1. It needs 1 electron for stability. Coming back to our discussion, how will the bond be formed? This single carbon atom can share its 4 valence electrons with 4 different hydrogen atoms. It makes sure that each hydrogen atom attains stability by having 2 electrons in its shell, and even carbon gets 8 electrons in the outermost shell. How? 1 electron from each hydrogen atom makes 4, and there are already 4 valence electrons with carbon. These sum up to attain the octet state. This is how a methane molecule is formed. A single carbon atom bonded with 4 hydrogen atoms. Each bond here is a single covalent bond. This is how single covalent bond formation between carbon and any monovalent element takes place. Now let's talk about the double and the triple covalent bonds formed by carbon. To understand this, we take a simple example of the compound carbon dioxide. Can you draw the typical molecular structure of carbon dioxide? Yes, it appears somewhat like this. 2 oxygen atoms bonded with 1 carbon atom. How is this bond formed, by the way? We know that the valency of oxygen is 2 while that of carbon is 4. That means out of the 4 valence electrons, 2 electrons will be shared with 1 oxygen atom while the remaining 2 with the second oxygen atom. But sharing means both the atoms will participate in the bond formation, right? That is why at the same time, each oxygen atom also shares 2 electrons with carbon atom. Such type of sharing enables the atoms to attain stability. Wait a second, did you notice that there are 4 electrons or simply 2 pairs of electrons shared between each oxygen and carbon atom? Yes, that makes it a double covalent bond, right? Absolutely. Now lastly, we take the example of a triple covalent interaction of carbon. Have you ever come across the compound hydrogen cyanide? Yes, it's an extremely poisonous liquid used for experiments in laboratories. Do you know what its chemical composition is? It's HCN. So do you know what the structure looks like? It looks like this. Yes, 1 carbon atom attached to 1 hydrogen atom and 1 nitrogen atom. Now if you notice, the valency of hydrogen is 1. That means 1 electron of carbon is shared with this hydrogen atom. Moving to the other side, the electronic configuration of nitrogen is 2,5. That means it needs 3 electrons to complete its octet, right? And we have the carbon atom waiting to share its 3 electrons. But we know that sharing involves electrons from both the atoms. That is the reason why even nitrogen contributes 3 electrons for participating in the bond formation. Remember, a covalent bond always requires sharing of electrons. So that is how 6 electrons are shared between these 2 atoms. Thus, 3 pairs of electrons gives rise to a triple covalent bond between the carbon and nitrogen atoms. Now this was how carbon forms various covalent bonds with other elements. Is this the reason why carbon forms so many compounds? Well, this is definitely one of the major reasons why carbon compounds are widely found. So what could be another reason? One extremely important property of carbon is to form bonds with itself. Yes, a single carbon atom can form multiple bonds with other carbon atoms to give rise to massive carbon chains. This property is called catenation. Let's understand the property of catenation in the upcoming video.